Ever been stuck in bumper-to-bumper traffic, wishing you could just fly over it all? Well, that future might be closer than you think, thanks to a concept called urban air mobility, or UM. Welcome to Summarize Science, where we break down the latest research for you. UM is essentially an on-demand air taxi service using quiet, electric aircraft that take off and land vertically, kind of like a futuristic helicopter. Researchers at Purdue University wanted to know, could this actually work in one of the most congested places in the U.S., the San Francisco Bay Area? They decided to build a detailed computer simulation to find out. Their virtual network connected 4 key airports: San Francisco, Oakland, San Jose, and Palo Alto. They based their simulation on a real aircraft, the Archer Midnight, which can carry 4 passengers and has a range of about 60 miles. The goal was to see if these flying taxis could handle real-world demand, especially during peak hours. To make the simulation realistic, they used actual passenger travel data to predict how many people would request a ride between these locations at any given time. This map shows the direct flight routes they analyzed, which are all well within the aircraft's range. They modeled a full 20-hour operational day, from 5 a.m. to 1 a.m., including the 10 minutes needed for recharging between trips. So, what were the key questions they wanted to answer? First, and most importantly for users, how long would you have to wait for your flying taxi to arrive? Their target was an average wait time of 10 minutes or less. They also wanted to see how efficiently the fleet of aircraft would be used. And the results were incredibly promising. Looking at this chart of passenger wait times, the simulation showed an average wait of just 7.47 minutes. That means for most of the day, you could book an air taxi and be on your way in less time than it takes to get a coffee. A large percentage of riders were actually picked up in under 5 minutes, showing the system was very responsive. The simulation also revealed that the San Jose airport was the busiest hub, with the most incoming and outgoing flights. In fact, the fleet was so busy that the aircraft were flying passengers over 85% of the time. So let's recap what this all means. This research strongly suggests that an urban air mobility network in a busy area like San Francisco is not just a sci-fi dream, it's operationally feasible. The simulation proved that a fleet of electric air taxis could handle passenger demand, provide a fast service, and keep wait times incredibly short. While the system was highly efficient, the researchers noted that a few extra aircraft might be needed to handle unexpected rush hour spikes, ensuring those wait times stay low. So, what's next? Future studies will add even more complexity, like weather patterns, air traffic control rules, and adding more pickup spots in cities like Berkeley and Fremont. This simulation is a major step forward, providing a data-driven blueprint for how we might one day skip the traffic and fly to work instead.